All right, here is today's teaching video for Monday, February 8th. So we're going to start off by taking some notes. So you need to grab your math notebook and a pencil. If you need to push pause on the video to go and do that, please do so now. All right. So in your notebooks, we are going to go through a lot of these terms that you see here. So get your pencils ready and let's get going. So the first thing that I want you to write down in your notebook is the title fractions. All right, so the title of our notes today, fractions. We are going to go through some basic fraction vocabulary and concepts just to get your mind ready for where we're going with our new lesson. So the first thing that I want you, after you put down the title, is to go ahead and we're going to talk about fractions are a part of a whole. So when we're talking about fractions, you have the part on top, and the bottom represents the whole, or the total amount of pieces that something is broken up into. So it's part over whole. And again, while we're taking notes, at any time you can pause the video so that way you can catch up. All right, so now we're going to identify what represents the part and what vocabulary word represents the total. So the top number that represents the part in our fraction is called the numerator. And the downstairs number is called the denominator. So for example, if I had something that looked like this, and let's just say that this represented a tray of lasagna and it was cut up into pieces like this, the total number of pieces is the denominator. It shows how did we break up the whole. Then the top, if I shade in one piece, my numerator would be a 1. If I shade in 2 pieces, my numerator would change to a 2. It's the part of the whole that we're looking for. All right, so the next thing that I want to talk about is a unit fraction. So let's write down unit fraction. All right. So a unit fraction, I'm going to give you some examples first. So we have 1/3, 1/8, 1/9, 1/12. These are all examples of unit fractions. So take a look. What do they all have in common? Hopefully you realized that they all started with a 1. So they all have a 1 in their numerator. So this is a unit fraction because it's talking about one unit or one piece. So if I had my model here, and in this case, I broke it up into thirds. 1/3, this is another third piece, and this is a 1/3 piece. Each of these pieces represents one unit of the whole. Again, if you need to push pause to catch up on the notes, please do so. I'm going to go ahead and clear my screen so that way I have some more room to write. So the next thing I want to talk about is a whole number as a fraction. So whole number, and I'm going to use the abbreviation numbers. All right, so if I have the number 3, I could write that as a fraction just by doing 3/1. That means 3 wholes. The number 5 would be 5/1. If I had the number 10, it would be 10/1. You can write any whole number as a fraction just by giving it the denominator of 1. This means 3 wholes, 5 wholes, 10 wholes. So something else that we like to talk about when we're dealing with fractions is improper fractions. Improper fractions. So I'm going to list some examples of improper fractions, and then try and see if you can list some more examples that would fit what you say. 9/5 is an example of an improper fraction. 12/3. Let's see here. We can go 15/2 or 4/3. So taking a look, what do they all have in common? Can you come up with your own example? So improper fractions have numerators that are larger than the denominator. So you can see that the 9 is bigger than the 5, 12 is bigger than 3, 15 is bigger than 2. That's because all of these fractions are greater than 1, greater than a whole. So improper fractions have a value that is greater than a whole. So then we also have something called mixed numbers. So again, please pause the video at any time so you can write in your notebooks. So I'm going to hop over to the left part of the screen and you're going to see I'm writing mixed numbers. So mixed numbers are, if you think about like your shoe size, maybe you wear a 6.5. That's an example of a mixed number. 8 3/4. Maybe if you're cooking and you need a lot of flour, maybe you need 1 1/3 cup of flour. So a mixed number is made up of a whole number and a fraction. Mixed numbers are also greater than a whole because that means I had 6 wholes and a little bit more. I had 8 wholes and a little bit more. I didn't quite get to the next whole number of 9. I have a value that's in between. All right, so let's take a look at a couple more concepts that are really going to help us on our journey of fractions in the next few lessons. So the next 3 parts that we want to talk about are equivalent fractions, part of a region, and part of a set. So let's go ahead and write equivalent fractions in our notes. And all of these concepts have been taught in 3rd and 4th grade. So this is a little review. Equivalent fractions. And what's nice about equivalent fractions is we've used the term equivalent before when we used equivalent decimals. And you can see right here, EQUAL, something that is equal. So equivalent fractions are fractions that represent the same value. They're equal to each other. So if I have this picture here of halves, and I have this picture over here of fourths, if I shade in 1/2 over here to represent the same exact value, I would have to shade in not 1 piece, but 2 pieces. 2 out of the 4 pieces. But you can see that they still have the same value because they both show that this much of our shape is shaded. So we're going to be doing a lot with equivalent fractions. So now let's talk about the last 2 parts, part of a region and part of a set. So if I wanted to model regions, regions are when you take something and you break it up into pieces. So examples would be like, if I have this rectangle, I break it into thirds and I shade in 1/3. Maybe I have a circle and I break it up into fourths and I shade in 3/4. So a region is when you are taking a shape and you are cutting it into equal parts and then shading. A set is a little bit different. A set is when, let's say I have a circle, a circle, a star, a circle, and a star. And I want to know what fraction of my images are stars. Well, in this case, I would say I have 2 stars out of 5 shapes. So in this case, the stars become my numerator and the total shapes. Because remember, when you're thinking about fractions, it's always part over whole or part over total. So that's why it's not stars over circles, it's stars over the total shapes. And that represents a set. So if we were thinking, if somebody said, hey, Mrs. Reggiani, what fraction of your students are girls? I would say however many girls I have in class as my numerator, and my denominator would be the total number of students that are in the class. Or if it was how many students have brown hair, same thing. However many students, when I count them up, that have brown hair become my numerator, and the total number of students becomes my denominator. So again, now that you have those in your notes, and if you missed anything, all you need to do is push pause, rewind, watch the video as much as you need to in order to write these down in your notebooks. So here, you are going to go into the Nearpod, Student Pace Nearpod that's posted with this video. And you are going to push pause on this video and you are going to try this problem yourself. I want you to show me, what does 1/6 plus 2/6, what is its answer? And how can you show me what this problem is? Using a model, a number line, fraction tiles. So again, you need to open up that link that is on the Google Doc, and you're going to click the Student Pace Nearpod, and you are going to go ahead and answer this problem. When you're ready, come back and push play on the video. All right, welcome back. So there's a couple different ways that you can model this problem. I have 1/6 piece plus 2/6 pieces, and we need to figure out what is the sum. So maybe you chose to draw a model. So you're going to start with, well, my denominator is 6, so we're going to start with 6. So I'm going to draw my whole. I'm going to break it up into 6. All right, so let me shade in my first add-in, which is 1/6. So you can see I have 1/6 pieces shaded in, and then I have to color in 2/6 more. So let me switch my color up. All right, so now I need to shade in 2/6 more. So you can see when I take the one piece that's purple and those 2/6 pieces more, I get a sum of 3/6 as my answer. Maybe you're also noticing that, wait a second, this looks like half of my whole entire rectangle. That's because you just thought of an equivalent fraction. 3/6 is equivalent to 1/2. Another way you can do this is maybe you were thinking, well, I could probably model this on a number line. And maybe that was what you chose to do. So your number line should start with 0, end with 1. And then because we have the denominator of 6, I need to break apart my shape into 6 equal parts. That means I did 5 lines. So you can see 1, 2, 3, 4, 5 lines make 6 pieces or 6 spaces. 1, 2, 3, 4, 5, 6 spaces. So here would be 1/6, 2/6, 3/6, 4/6, and 5/6. One whole is the same as 6/6. So now I can jump on my number line to show my thinking. So you can see I'm going to start with 1/6. So I went from here to here. And then I have to go 2/6 more. So 1/6, 1/6, and I end up right at 3/6. So again, another way to model this problem. So on this next slide, this is a try it problem. So what that means is I haven't really taught you anything new about our lesson, and I want to see what you can tap into with prior knowledge and how you can approach this problem before I teach you the lesson. So it says, Raul needs 1/2 a stick of butter to make cupcakes. He needs 1/4 a stick of butter to make the icing. What fraction of a stick of butter does Raul need in all? So the story problem is about Raul. He's using butter to make cupcakes and icing. It says that he needs 1/2 a stick of butter for the cupcake batter. He needs 1/4 stick of butter for the icing. And you're being asked to tell me how much total butter does he need in all to make his cupcakes with icing. You are going to go ahead back into the student paste Nearpod that is posted in the Google Doc, and you are going to show your work there. Tomorrow in our live class, we're going to share strategies and talk about how to solve this problem. If you have any questions, you can reach me through email, or you can join me tomorrow, Tuesday, during office hours. I do want to remind you that you also have another requirement is you have to do your iReady equivalent fractions posted lesson.